Today is the last installment of PGT educational videos. The focus of today will be mosaicism. Mosaicism describes an embryo in which there is the presence of more than one chromosomally distinct cell line. That's a really complicated way of saying it looks like some of the embryo cells have a certain chromosome makeup, while other cells have a different chromosome makeup. Maybe some percentage of the cells have 47 chromosomes with an extra chromosome 21, while others have 46. Or maybe some cells have 45 chromosomes with a missing X, and other cells have 46. Aside from the embryo being truly a mosaic, there are several reasons to explain this finding. Studies have reported incidences of mosaicism ranging from 2 to 26%. Needless to say, I talk about this all the time with patients. When we see mosaicism on a report, we don't know if the inner cell mass, or what will become the actual fetus, is aneuploid or euploid or mosaic. We do know that a mosaic embryo may result in no implantation, a miscarriage, a child with no health issues, or a child born with variable physical and intellectual issues that can range in severity. That severity depends on the level and location of mosaic cells and the chromosome material involved. Mosaic embryos can be classified as low level or high level. Low level means that 20 to 40% of the cells are found to be mosaic, while high level means that 40 to 80% of the cells were found to be mosaic. Generally speaking, low-level mosaic embryos have been reported to have a better reproductive outcome. As of 2023, there have been over 2,700 documented embryos transferred with mosaic results, leading to a gradual but increased acceptance of the transfer of mosaic embryos. Mosaicism identified in a pre-implantation embryo has thus far not been definitively associated with a significant increased risk for adverse fetal or neonatal outcomes. But most of the studies have focused on prenatal and newborn outcomes. There are no long-term outcome studies available to speak of. This concludes the PGT series. There are two other forms of PGT that are available: pre-implantation genetic testing for monogenic conditions, or PGTM. That may be used to screen an embryo for a known genetic condition present in the family, and pre-implantation genetic screening for structural rearrangements, or PGTSR. This is done to assess for certain structural changes in the embryo's chromosomes. The basics of PGT that have already been covered apply to both of these, and given the case-specific nuances, it is recommended that patients speak with a genetic counselor at their testing laboratory regarding the availability and requirements associated with their case. As always, if you have any questions, you are welcome to schedule an appointment at www.storkgenetics.com.